Hello everyone, welcome back to my YouTube channel Maths by Arshit. In this video, I'll discuss question number 4 and question number 5 of exercise 1.1 of NCERT mathematics. So let's start the question. Show that the relation R, this relation R on R in R is defined by R equals to A comma B such that A less than equal to B, and we need to prove it is reflexive, transitive but not symmetric. The relation is not symmetric. I'll change the color in this video. So what is A here? A is complete R, and what is relation R is here? R is collection of all those ordered pair, collection of all those ordered pair such that A is less than equal to B. Here you observe A is an infinite set. A is an infinite set. So it is very typical to find the R completely, okay, or to write the R, each element of R. So what we need to do, in general we are explaining, if some properties fail, then we need to give counter, then we will give counter example. Okay, so start with reflexive. For reflexive, for reflexive, recall the reflexive property. Reflexive says if each element of set A related to itself, then we say relation R is reflexive on R. So here observe, for any A belongs to R, that is capital A is less than equal to A. You can observe, because equalities always hold. As you already know, meaning of this one is, suppose x is less than or equal to y. How we read it? X is less than or equal to y. If one of the condition is hold, then we can use this inequality. Okay, here equality is hold, that's why we are using this inequality. Okay, so it implies that if this property is hold, according to this one, what implies, according to this one, what implies, if this property is hold, a comma b has to be in relation. So here a comma a belongs to R, and as a is any element of a real number, set of real number, so it means this property is hold for every a. It means every element is related to itself. We can write here every element of a equal to R is related to itself. Okay, so this implies R is reflexive on A. Done? Okay, now for symmetric, we need to check for symmetric. Symmetric means, recall, a comma b, we need to choose to real number, we need to choose real number. A comma b belongs to R, and from the set A, and if a comma b, if a comma b belongs to R, then we need to check, we need to check b comma a belongs to R or not. Okay, this thing we need to check. If this property is hold for every ordered pair, then we can say it is symmetric. But observe here, but here we need to observe, if a equals to 1 and b equals to 2, 1 comma 2 belongs to R, relation R. Why? As, because you can write, because 1 is less than equal to 2, because strict inequalities hold, so we can use this inequality. Because as I said here I said if one of the inequality is, if one of the condition is hold, then we can use this complete inequality. So here 1 is less than 2 strictly, so we can use this one. Okay, but problem is here come, 2 is not less than equal to 1, neither it is less than or nor it is equal. That's why none of the condition is hold, so that's why we are saying this thing. And if this is saying we have this thing, then 2 comma 1 does not belongs to relation R. 1 comma 2 is there from first, but second we observe that 2 comma 1 does not belongs to R. It means there exists an element for which the reflex symmetric property is not hold, hence R is not symmetric on set of real number. Okay, so this property is hold, this property is not true. Now for transitivity we need to check. For transitive, how we can check transitive? Let A comma B and C belongs to R such that A comma B belongs to relation R and B comma C belongs to relation R. What it implies? A comma B belongs to R, it means A is less than equal to B. This is first inequality inequation, and B less than equal to C. This is second inequation. If we combine both of them, what we get? If we combine both of them, what we get? A less than equal to B less than equal to C. So this implies A less than equal to C. And if A is less than equal to C, then it implies A comma C belongs to relation R. Okay, so here we observe that in general we are proving this thing. So here R is transitive. R is transitive on A equal to set of real number. Okay, and here one thing we observe that relation R is not an equivalence relation. Relation R is not an equivalence relation. Why so? Because it is not symmetric. Why? Because it is not symmetric. That's why. Okay, so I hope you understand this question. Move on to next question. Next question is this one. Check whether the relation R, again we have a set of A is a real number. So I'll start the question. What is A here? A is a set of real number, and define relation R. How they define? Relation R they define like that. It contain all those ordered pair for which A is less than equal to BQ we have. Okay, so where A comma B belongs to R, it is subset of, what is subset of? R cross R we have. Okay, R cross R we have. Now obviously we need to start from the starting. As they said, we need to check reflexive, symmetric and transitive property. So for reflexive we need to check. For reflexive we can observe that 0 comma 0 satisfies this property, 1 comma 1 satisfies this property. Both these two elements related to itself, but because of these two can we say it is reflexive? No, as we observe that 2 belongs to real number also, but 2 comma 2 does not belongs to R. Why so? Because 2 is not less than 2 cube. Why? Because 2 is not less than 2 cube. Now this property satisfy. This property is satisfy. This is also satisfy. Okay, yeah. Even we can observe that if A is a real number and A is greater than 1, if A is a real number and A is greater than 1, guarantee this property is hold or not. So for all of them, a comma a belongs to relation R. But observe that we can take, okay, if a is 1 by 3, yeah, here is the problem. If a is 1 by 3, then 1 by 3, 1 by 3 cube, because it belongs to real number, it is also in real number. 1 by 3 is greater than 1 by 3 cube. Why so? Because it is 1 by 27 we have. So it implies that 1 by 3 comma 1 by 3 does not belongs to relation R. Relation R. So this implies that R is not reflexive. See here, you can observe that we have infinite elements here. We have infinite elements here for which we have a comma a belongs to R. But there exist even not only this one, 1 by 2 also does not satisfy this property, 1 by 5, 1 by 7, 1 by 9. All the elements which are in between 0 and 1 does not satisfy this property, and it is not reflexive. So infinite element does not satisfy, and infinite element satisfy this property. So you can differentiate what is a reflexive. Okay. Now for symmetric. For symmetric means, symmetric is, what we have symmetric, if a comma b belongs to relation R, is b comma a belongs to R? That is our question. If a comma b belongs to R, is b comma a belongs to R? So observe that if I choose a equal to 2, okay, if we choose a equal to 2 and b equal to b equal to 10, we can choose or not. So here you observe 2 comma 10 belongs to R, because 2 is less than equal to 10 cube. Property satisfy? Okay. But again problem came. 10 comma 2 does not belongs to R. Why? Because 10 is not less than equal to 2 cube. Why? Because 2 cube is 8. Okay. None of the conditions satisfy. So this implies from here and from here R is not symmetric, because there exists an ordered pair for which symmetry is not true. R is not symmetric on R. Okay, I think you understand. Okay, now transitivity we can check. For transitive, how we can check transitive property? See here. So if a comma b belongs to R, b comma c belongs to relation R, then what we need to check is, we need to check a comma c belongs to R or not. Okay, this is our task. Now see here, again I have a counter example. Okay, a equal to, if I assume 18, b equals to 4 and c equals to 2. See, 18 comma 4 belongs to R. Why so? Because 18 is less than equal to 4 cube, 4 4 16 64. Okay, and here What we have here at the end? Yeah, here we have 4 is also 4 comma 2, 4 comma 2 belongs to relation R, as 4 is less than 2 cube, that is 8. But 18 comma 4 related to R, 18 comma 4 belongs to R, 4 comma 2 belongs to R. We need to check, is 18 comma 2 belongs to R? So answer is no. 18 is not less than 2 cube, because 2 cube is 8, obviously. Okay, so it implies that, so we get ordered pair or not? We get pair of ordered pair for which transitive does not satisfy. R is not transitive. R is not transitive on R. So here R is neither reflexive nor symmetric nor transitive. Okay, I hope you understand both these questions. Thank you for watching.